So today we're going to actually solve some trig equations, and I'm going to preface that with these are trig equations with no identities. You don't know what an identity is yet, so just take it for what it's worth. Let's just do an algebra problem real quick. If I have 2x equals 1 and I wanted to solve for x, I divide both sides by 2, correct? And get x equals a half. Well, now what we have is we have something like the sine of w is equal to a half, and we want to find the values of w between 0 and 2 pi that satisfy this. So in order to find the values of w, I have to isolate w. We know the only way to do that is actually take the inverse sign of the equation. So now we're asked where between 0 and 2 pi do I have a sine value of a half? Well, that would be here and here. And those values would be pi over 6 and 5 pi over 6. Done. So you'll see that what we're trying to do is get the sine, cosine, tangent, whatever value equal to some number, take the inverse of it, and then find that value on the unit circle. That's kind of the goal for the day. So we're going to do the same with the cotangent. Take the inverse cotangent of both sides, so w equals the inverse cotangent of -1. And we know that since we're asked to find all values of w, this is going to be a little bit more different, because if I want to find cotangent values of -1, then those would be here and here. And not only here and here, since I'm asking for all values, it's just not between 0 and 2 pi, it's everywhere. So this is at 3 pi over 4, 7 pi over 4, which you'll notice are pi away from each other. So basically what I'm going to say is that my answer is 3 pi over 4 plus any 180 degree multiple or any pi multiple of that. So I'll say plus pi k, where k is an integer. All right. In this case, the problem's a little bit different in that we don't have a singular function. It's kind of like an equation that we have to solve. So I'm going to combine like terms. I'll bring the let's bring the 1 over and the 2 sine w over. So that gets us 2 sine w. Divide by 2 to both sides. So sine of w is equal to a half. And then w is equal to the inverse sine of a half. And where is the sine equal to a half? We've done a problem like this before, here and here. I know that's a pi over 6, 5 pi over 6. The problem is there's no real relationship, or I can't go around 180 degrees and get to the other guy. So we're going to need, since we're asked to find all solutions, to state, well, this is at pi over 6, and then anytime I go all the way around again, I get another value of a half. So this is plus 2 pi k, and it's also at 5 pi over 6 plus 2 pi k. Give me all the solutions, not just the solutions between 0 and 2 pi. Find all the solutions of this problem. You'll notice now we have a squared term in here, which creates a quadratic. So I'm going to take and set everything equal to 0, because that's how we deal with quadratics. We're going to factor, so that's 2 cosine w times cosine w. I need to multiply to 3 and get a -1 when I add up. So that's how that's going to work. So now you'll notice I have two equations I have to solve. Where does the cosine of w minus 3 equal 0, and where does the cosine of w equal -1? Well, this asks where does the cosine of w equal 3 halves, and therefore we take the inverse cosine of 3/2 and let that equal w. Well, this asks where on the unit circle, since I wouldn't give you a calculator for this, do you get a cosine of 1.5? That's never going to happen. We've talked about this before. Cosine fluctuates between 1 and -1. Therefore, there's no cosine value of this. This is an extraneous solution. But here I can find out where an x value is -1. Happens to be right here. So my solution would be at pi plus 2 pi k. Because every time you go around again, you'll get that solution. We have another set of quadratics. I will take and set aside equal to 0. So tan squared w times cosine w minus tan squared w is equal to 0. Definitely don't divide by tan squared to both sides. You'll lose a root. Factor out of tan squared. Get cosine w minus 1. Two equations to solve for. Where does tan squared of w equal 0, and where does cosine of w equal 1? Therefore, I have where does the tan of w equal 0, or w equals the inverse tan of 0, and in this case, w equals the inverse cosine of 1. On my unit circle, where do I get a tangent value of 0? It's wherever my y value equals 0. So here and here my y value is equal to 0. Therefore, for this portion, I would get 0 plus pi k. And then where does the cosine value equal 1, or where is my x value equal to 1? That's the only place. So you'll notice that if I were to state pi, or 0, plus 2 pi k, that actually includes all these values. So I could just state, that'll do it. This next problem's a lot trickier. Here's what we'll do. We'll find all the solutions once again. You'll notice, though, that I have the cosine of this giant quantity is equal to 1/2. Well, I'm going to have to get rid of the cosine to isolate the w. So in order to do that, I have 2w plus pi over 6 is equal to the inverse cosine of 1/2. Now this is a unit circle problem. Let's take a look at where that happens. My x value of positive 1/2 would be here or here, which is at pi over 3. But since we're looking to find all values, this would be at 5 pi over 3. And if I were to go 2 pi around every time, I would get a new answer. Now, all that does is satisfy this part of the problem. So the next thing I'll have to do to find w is I'll have to take and say 2w is equal to the inverse cosine of 1/2 minus pi over 6. And then to that, I will have to take and multiply both by 1/2. So, if this was my cosine, our cosine of 1/2 solution, I have to multiply these by 1/2 and then subtract pi over 6 from that. So let's go ahead and do that. I'll do that in blue so we know what we're doing. I'm going to take and multiply this by a half and then subtract pi over 6 from it. Multiply this by a half and subtract pi over 6 from it. So what I have is I have pi over 6 plus pi k minus 1 pi over 6, and I have 5 pi over 6 plus pi k minus pi over 6, which in this case is just pi k, and in this case is 4 pi over 6. I could say 2 pi over 3, but I'll leave it like that, plus pi k. And these are my two solutions. The problem is fairly tough. So the last thing we're going to do is we're going to use a calculator to go ahead and solve this problem. First thing you're going to want to do is, since we're looking to find values that are between 0 and 2 pi, make sure your mode is correct. So I'm in radians. And secondly, we're going to set our window, because we're going to do this through a graph, starting at 0 for x and going to, let's go 2 pi for the max part. We know that sine and cosine very rarely move, even when adding and subtracting, move between 1 and -1. So we're going to go from -3 to 3. And then we're going to go to y equals. If you have anything in there, clear it out. And say we have sine of 2 theta, which is like 2x, close your parentheses, plus cosine of x. And then for a second graph, I'm going to graph 0. When I go ahead and graph that, here's what it looks like. And what I'm looking for is I'm looking for where does this graph equal 0. So I'm looking for 1, 2, 3, 4 intersections is basically what I have. So I'll go to calculate, intersection, and it'll ask me to choose the two curves. And I'm going to just go right here first. Let's do it again because it didn't come up. Calculate the intersect. 1, 2, 3. And I get an intersection of basically 1.57 radians. That's one place. We'll go back to my calculator, calculate the intersection again, move it over to the second intersection. Get about 3.66. Go to my calculator again. Second calc. Intersect. Get it over to the next intersection. About 4.71. We got one more intersection to do. So calculate, intersect, move over to this last guy. And hit 5.76. And that's where all my values are, such that sine of 2w plus cosine of w is equal to 0. And again, I tell you I want you to use a calculator for something like that. And that's all we've got. Fill out your lesson summary and do my math lab. See you tomorrow.